Hello everyone! In this lesson, we'll study the specific application and complementary settings of RI/RO in FANUC robots. First, let's learn about the menu control of our robot I/O RI/RO. Robot I/O RI/RO is manual control method. It's relatively simple. When RI is not in the simulation status, its status is determined by external signals. When it's at a high level, it's on, and at a low level, it's off. Next, let's look at the practical operations.
There are two ways to enter I/O. The first is through the menu key, and the second is through the I/O key. First, let's look at the first one. Click Menu, then select 5 I/O, and then select 6 Robot. Now we enter the I/O interface. Next, we directly click I/O and select 6 Robot. Then we also enter the I/O interface. We can move the cursor here and use in-out to switch between RO and RI interfaces. For example, we change the state of R1 to on and the state of R2 to off. Here, we can directly switch the state of RO. Then we can see simulation here. If we set this simulation to S, it will be in a simulation state. In this state, all simulated port operations in the program are an emulated state without any impact on peripheral devices. Therefore, when you found that the actual state of the I/O point can't be changed in the program, you can check whether the simulation state is set here. Cancel the simulation state, then we enter RI and set the state to S before we can switch its state on or off.
Next, please answer this question. In FANUC robots, what determines the status of RI when not in the simulation state? A. Internal program. B. External signal. C. System variable. D. Robot position. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Next, let's learn about the program control of robot I/O RI/RO. There are mainly 2 types of I/O program control instructions. The first is directly assigning on or off to a specific point. For example, RO equals on or off. When assigned on, the corresponding output signal RO is turned on. If off, the corresponding output signal RO is turned off. The second is pulse output. It supports pulse-wise settings from 0.1 to 25.5 seconds. If no time is specified, the pulse width is determined by the system variable DEPULSE with the unit of 0.1 seconds. ROI equals pulse 1.5 SEC, meeting a 1.5 second pulse. Next, let's look at practical operations.
We create a program test. Click Edit, then click Next. Click Instructions, then click I/O. Click RO. Here, we enter the corresponding serial number directly. Enter 1. Then we make it on. Continue the operation before. Click I/O and click RO. Enter 1 again. Click off. And then repeat the operation before. We continue to set RO1. Then click pause and set it to 5. 5 means that this pause width remains for 5 seconds. Next, let's run this program step by step. We click Shift and then click FWD. Now, this program has been running. Now we can click Dual Screen and then we click I/O. We need to remove the Shift button and then we can see on the screen interface that the state of RO has become on. Next, let's run this program again. Alright, click Enter. Then let's run the program again. Click FWD. Run it again. It's on now and it becomes off and then changes from off to on. Look carefully. After 5 seconds, it will become off again. This is the operation method of RO.
Next, please answer this question. Which of the following instructions is used to set ROI as the 1.5 second pulse output in a FANUC robot program? A. ROI equals on 1.5 second. B. ROI equals pulse 1.5. C. ROI equals pulse 1.5 second. D. ROI 1.5 second pulse. I will give you 5 seconds to think, and we will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Next, let's learn about the complementary settings of robot I/O RO. If the opening and closing of a gripper cylinder are controlled by 2 RO signals respectively, simultaneous activation of both RO signals due to programming errors or misoperations will cause gripper control to fail and may lead to accidents. Therefore, it's necessary to set these signals, and meanwhile, only one can be on, while the other must be off. This setting is called complementary setting. Next, let's look at the practical operation.
Let's take a look at RO1 and RO2 again. Now, each state can be set to on. How should we set the complementary configuration? First, click Next page, then click Details. Let's take a look at again. Set them all to off before setting them. In this interface, we see that there is a comment. Enter AA in the comment of the robot output 1. Click the next signal, which is the robot output 2. Now, let's focus on 1. In the polarity column, normal is high level. Reverse means that the low level is valid. If this option is set, it must be restarted to take effect. The third option is complementarity. After we click Enable, the software prompts us that we need to restart. Alright, let's restart the system. After we re-enter this interface, we see that RO1 and RO2 are both off. When we set RO1 to on first, and then set RO2 to on, RO1 becomes off. When RO1 is set to on, RO2 is off. So RO1 and RO2 are set to complementary states, and they can't be on at the same time.
Next, please answer this question. Which of the following descriptions about FANUC robot I/O control is incorrect? 1. When RI is not in the simulation status, its status is determined by external signals. B. RO can be directly assigned on or off through program control. C. The pulse output instruction can be a specific pulse width. If unspecified, the system default width is used. D. The complementary setting of RI and RO is to ensure that both signals are on simultaneously. In any case, I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is D. The correct statement can be the complementary setting of RI and RO is to ensure that the two signals is on at any time. Did all classmates answer correctly? Okay, everybody, after this lesson, please complete 2 tasks. Task 1. Write a program to control an indicator light to flash 3 times using RO, 1 second on, 1 second off each time. Task 2. Set complementary settings for 2 RO signals and verify the interlock effect. Everybody, see you next time.